Let's consider for a moment this rational equation. 2 over x equals 3 over x. It should be self-evident that this has no solution. Why is that self-evident? What this is claiming is there is a number that if I divide 2 by it or 3 by it, I get the same thing. That's clearly not going to work. But look what happens if we cross multiply. We get the equation 2x equals 3x. Subtracting 3x from both sides, we see that this has a perfectly good solution, namely x equals 0. What's happened here? The process that we've been using to solve this equation has introduced what's called an extraneous solution. What is an extraneous solution? An extraneous solution is an apparent solution to some equation that we find by going through a process that will give us solutions that was not actually a solution to the original equation. Why does this happen? We may create an extraneous solution anytime we take a solving step that is not reversible. What do I mean by reversible? This is the process we use to solve a linear equation. Say we want to solve the equation 3x plus 8 equals negative 4. We subtract 8 from both sides. We get the equation 3x equals negative 12. Then we divide both sides by 3, and we get the equation x equals negative 4. We could have done this whole process backwards. We could have started with x equals negative 4, multiplied both sides by 3. If two things are equal, we multiply them both by 3. The result is still equal. And then we could have added 8 to both sides and gotten back our original equation. So all of these steps were reversible. We'll never have an extraneous solution to a linear equation. What irreversible step did we take in solving our equation 2 over x equals 3 over x? Well, here's the thing. That process that we used, cross-multiply, it's an illusion. What we've really done is multiplied both sides of the equation by x, which we decided gave us 2x over x equals 3x over x. And then, because we were cross-multiplying and not taking advantage of the fact that these denominators were the same, we simplified one side, multiplied both sides by x again, and that gave us our 2x equals 3x. But when we were multiplying both sides by x, what was that extraneous solution? The extraneous solution was x equals 0. When we were multiplying both sides by x, invisibly, we were multiplying both sides by 0. And of course, we can make any two things equal by multiplying by 0, right? That would be like saying, I want to find a solution to the equation 7 equals 8. What? Well, if I multiply both sides by 0, I get 0 equals 0. Hey, I guess 7 equaled 8. No, of course not. What does that mean? Let's get back to something a little bit more concrete. In solving a rational equation, we will regularly multiply both sides of an equation by a variable expression. Any value of the variable which makes this expression 0 can't be a true solution, but it may appear as an extraneous solution. All right. Let's see a specific example. Suppose that we multiply both sides of an equation by the expression x plus 4. Then if, as we continue to solve, x equals negative 4 appears as a solution, it's an extraneous solution. It came about because we multiplied both sides by 0. If we multiply both sides of an equation by x minus 3 at some point, what value cannot appear as a true solution? Pause the video and try to work that out. Well, it's the value that makes x minus 3 0. X equals 3 cannot appear.